Welcome back to part 2 of Module 7, Lesson 1, Relationships Between Two Variables. Now we're going to go back to the arcade again for a few minutes and say that suppose it still costs 25 cents to play one game at the arcade. The total cost of playing any number of games at the arcade can be represented by the rule 25 times G. Go ahead and highlight that, where G is going to be the number of games played. You can use a table to find the independent variable, otherwise known as the input, if you know the dependent variable, otherwise known as the output. So for example, if you knew that 25 cents times some number of games equal to $1.75, all you'd have to do is isolate the variable, as you can see right here, dividing both sides by the 0.25, and when you do that, you end up getting that the G, the cost of the number of games, is going to equal to 7, because 1.75 divided by 25 hundredths, or a quarter, is going to equal to 7. Now we can use the table we have down here below to repeat this process for $3 and for $4.25. But being big kids, we're going to have to show our work algebraically. So I'm going to start off with my formula. It says 0.25 times the number of games is going to equal to, and the first amount they had for us was $3. From here, all we have to do is divide both sides by 0.25, 0.25. Those divide out becoming 1 times G. That's going to equal to G, and $3 divided by 25 cents, that's going to equal to 12. So that tells me that we're looking at 12 games. So we're going to jump back over here, and I'm going to say that 12 and 0.25 times 12, that's going to equal to $3. Now let's do the same thing for the 425. So I'm going to change my pen color here. I'm going to do 0.25 times some number of games is equal to $4.25. I'm going to divide the variable by 0.25 on both sides. These divide each other out, becoming 1, and 1 times G, that's equaling G. 425 divided by 0.25, that's going to be 17. So the answer to the number of games for that one is going to be 17, which we will put here and here. We're going to check our answer, and the answer checks. Easy math. Anybody can do this, but anybody also needs to be using the supporting work, just like I'm showing you right here. Example 2 tells us that each small pizza at a local pizza shop costs $6.75. The total cost, C, that's our output, of P, that's our input, small pizzas, is equal to $6.75 times P. Make a table to find the number of small pizzas purchased if the total cost is going to be $13.50, $27, and $33.75. So let's start working on doing that. First, we need to recognize that the input is going to be the number of pizzas and that the output is going to be the total cost. Those check. Let's move to the next screen. To find the number of pizzas for each total cost given, we're going to use the work backwards strategy, otherwise known as undo multiplication by dividing both sides by the $6.75, and also known as using an inverse operation. So what I'm going to do is I'm going to take a screenshot of this table, and I'm going to post that over on my place where I can do my scratch work, and then we are going to work the problems together. The first thing I need to do is write my formula, and my formula is going to be the $6.75 times the number of pizzas is equal to, well, for the first problem, it's going to be $13.50. From here, we're going to take and divide both sides by 6.75. This is showing your work. Whoops, that's a 5 there. These can divide out to become 1. 1 times P is P. And when you divide these out, you're going to get 2. So for that, we put a 2 here, and we put a 2 here. Next, let's pick a different color to work with. We're going to take the 6.75 times P is equal to, right there, the $27. I'm going to take that one and divide both sides by 6.75. And that one's a little bit harder to do in my head, but I'm just going to take and do some quick estimations and try it out. 6 times 2 is 12, times 3 is 18, times 4 is 24, and times 5 is 30. So I'm going for 4. I'm going to say that I think P is equal to 4 right here, but let's find out for sure. So I'm going to take the 6.75 times 4. 4 times 5 is 20, 4 times 7 is 28, plus 2 is 30, 4 times 6 is going to be 24, plus 3 is going to be the same 27, bounce, 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 bounce. So yes indeed, it is going to be 4 pizzas for that one. Put in my 4 and my 4. And finally, we're going for that 33 count pizza. The 33 count is going to be, let's get my marker working here again. There it is. All right, I'm going to take and do another color here. Let's do a nice dark green. So for that one, I'm going to box off my work. I'm going to do 6.75 times P is equal to $33.75. And when I divide 6.75 on both sides, these still divide out becoming 1. 1 times P is going to be P. And when you divide 33.75 by 6.75, I'm pretty certain you're going to get 5. So our answers here are going to be 5 and 5. So let's jump over and check our answers. We're going to have a, here we go, a 2, a 2, a 4, a 4, and a 5, and a 5. Check it, and everything checks. I like it when a plan comes together. Now it's going to be your turn to do a problem. Now, on a plus side, I'm going to let you use a calculator on this problem. On a negative side, you also have to show your big kid supporting work just like I showed it right here. Make sure you're showing how you're isolating your variable for every single one of the problems. Go ahead and pause the video and do that right now. So did you get it done? Let me show you how I'm going to work these. I'm going to start off with the first one. This says, whoops, get my marker going here. $2.79 times P, and I honestly didn't need to read what P represents, is equal to $11.16. I'm going to isolate the variable by dividing both sides by P's friend. That's $2.79. These can divide out becoming 1. 1 times P is P. And then on the other side, I have the 11.16 divided by 2.79, and we're going to get 4 for our answer. So our first value for P is going to be 4. Draw a line to keep my work neat and organized with. And now let's pick a different color. Next one, I have $2.79 times P is equal to a $22.32. I'm going to isolate the variable again by dividing by 2.79 on both sides. This is showing your work, folks. That's what I'm looking for. These can divide out becoming 1. 1 times P is P. And then over on the other side, 22.32 divided by 2.79. That's going to equal to 8. So we're going to circle the 8. Need to go back and circle the 4 too. It's an answer. And we have one more problem to work. Once again, I drew a line to keep my work nice and neat and organized. And let's try, I wonder what gray looks like. Y'all probably can't see that gray too well. Let's try something different here. Let's go for, don't know what you call that color. $2.79 times P is equal to, the last one is going to be $33.48. And I'm going to take a wild guess here. I'm going to guess that the answer is going to be 12. I'll divide both sides by 2.79. 2.79. These divide out becoming 1. 1 times P, that's equal to P. And then I'm going to take my $33.48 divided by my $2.79, and hey, I'm so smart. How did I figure that out? I was looking at the patterns. Here I saw that 11 was doubled to 22, which gave us 8, and then they added another 11, giving us 33. That gave me a clue that I was probably going to get 12 for the right answer. So going back over here, we got to put our 12 in, we had to put our 8 in. That means on our actual problem, we're going to put a, oh, they want fancy answers here. They want a 4, they want an 8, and they want a 12. Check it, everything checks. Easy math. And that is going to be it for this lesson. Get started on your homework. Be sure, however, that you're giving me good quality supporting work just like I've been giving you here. Well, that's not showing up quite right. There you go. So that I can give you full credit for doing it. You've got to give me the big kid math if you want the big kid points. I'll see you in class tomorrow.